Hello everyone, thank you for joining us. We are Team JPQ, and today we will be going over our solution to the Spring 2024 CSI Hackathon. Our team consists of 5 members: Jennifer Chang, Jinja Zhu, Joe Zhao, Peter Lee, and Quinn Schmidt. When we first started this hackathon, the first thing we did was thoroughly read over the specification document in order to gain a better understanding of what we were trying to accomplish. From here, we isolated 4 specific points to consider when brainstorming possible solutions. These points were: how do we design a completely automated system that functions without human intervention? How fast do we need to move nests to and from the deep machine, given its 11-minute processing time? What does the CSI space actually look like? And how can we develop a system that is both reliable and cost-effective? Our design process started with a visit to the CSI space. While looking around the deep machine, we realized a few different things. 1. There wasn't a lot of space to move through around the deep machine. 2. There were several pathways near the deep machine that needed to remain open. 3. There was an emergency exit door near the deep machine that needed to remain accessible. With this information, we began working on a solution. Based on the given materials in the specification document, we settled on 2 possible ideas: either a series of autonomous ground vehicles or a conveyance system. With an 11-minute processing time and a distance of roughly 60 feet between the machine and storage area, both ideas seem promising in terms of getting the nests to and from the machine in a timely manner. That being said, we quickly realized that the biggest challenge to overcome in the CSI space was the space itself. With such a narrow space around the deep machine, various intersecting pathways, and an emergency exit door that needed to remain accessible, there was only one solution that seemed reasonable. That solution was an elevated conveyance system. Rather than using a series of expensive robots that constantly need to be recharged and that run the risk of running into both people and the CSI environment, we decided to create an elevated conveyance system running from the deep machine's nest drop-off point all the way to the storage area. By raising the system between 9 and 10 feet off the ground, the CSI space is able to remain completely open and unobstructed. Not only does our solution integrate seamlessly into the existing infrastructure, but it's also incredibly efficient and cost-effective. With a total transport time of just 75 seconds per nest, the deep machine could theoretically remain operational every second of the day, since it will never need to wait idly for a nest due to its 11-minute processing time. In other words, since one nest will always finish processing before another, our system guarantees to deliver a fresh nest to the machine before the next nest is ready to be delivered back to the storage area. In order to understand how this all works, it's important to get an idea of the different types of conveyors used in the system. We used 3 different types of conveyors in our solution. The first type that makes up a majority of the system's total length is the standard belt conveyor that is capable of moving both forward and backward. This allows for nests to be transported both to and from the deep machine using a single conveyor. The second type is a bidirectional lift conveyor. This type allows for both forward and backward movement, as well as movement to the left and right and up and down. This type of conveyor is used to pick up and drop off nests between the low-level conveyors that are directly next to the deep machine's nest drop-off point, and to lift nests up to the elevated conveyor level. The third type of conveyor is a standard lift conveyor that is able to move forward and backward and up and down. This type is used next to the storage area in order to transport nests to and from the storage area and the elevated conveyor level. This diagram is intended to show a top-down view of the entire conveyance system. The yellow arms extending out towards the 2 nest spaces at the deep machine's nest drop-off point are standard belt conveyors that stand at the same height of the deep machine's nest drop-off point. These 2 conveyors are responsible for picking up and dropping off nests directly to the deep machine. The red conveyor that intersects these 2 yellow arms is the bidirectional lift conveyor that is responsible for transporting nests between the 2 low-level conveyors and the elevated conveyor, colored in blue here. Finally, the red conveyor at the end of the elevated conveyor near the storage area is the standard lift conveyor that is responsible for picking up and dropping off nests to the storage area. Given the system's transport speed of nests, the deep machine's production is limited only by its own processing speed. This allows for maximum production of vials, given that the machine will never have to wait idly for an empty nest to be delivered for processing. With an average processing speed of 5.5 nests per hour, The projected yearly revenue resulting from 24/7 operation of the deep machine is estimated to be about $40 million a year. The total initial investment cost in our conveyance system is only $52,100, with a yearly maintenance cost of about $2,940. Given these figures, the estimated ROI of 24/7 operation of the deep machine using our solution is nearly 73,000%. After the first year, the estimated ROI is a staggering 1.36 million%. This marks the end of the speaking portion of our presentation. Please enjoy this short clip of our working conveyance system model in action.